A game consists of rolling two standard fair cubical dice. The numbers on the uppermost face are added to give a total. If the player rolls 2 or 12, they receive $20. If they roll 3 or 11, they receive $10. And if they roll 4 or 10, they receive $1. It costs $2.50 to play, and this is not returned if they win. They only receive the amount stated. Is the game fair? And if not, who stands to gain? And by how much per 100 games? First of all, consider the dice. You probably know this distribution, so I'll go very quickly. So we have one die at the top here, and the second one down the side here. And so we've got the totals in here, 2, 3, 4, 5, 6, 7. That's when we add the two dice. 3, 4, 5, 6, 7, 8. I won't carry on with this, but the point is that we can get any value from 2 through to 12 when we add 6 and 6. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's only 1 2 out of the 36 things in the grid, so that's 1 out of 36. And then you have 2 3s, so that's 2 out of 36. And if we continue, 3 out of 36, 4 out of 36, 5 out of 36, 6 out of 36, that's the most likely one. And then they go down again, 5 out of 36, 4 out of 36, 3 out of 36, 2 out of 36, and 1 out of 36. So let's just clear this area off because we might well need it. So let's look at this in terms of the winnings, or how much the player is up. So if they actually don't get one of the stated values, it's cost them $2.50 to play the game. So minus 2.50 is a possible value of X. If they get $1 winning, remember they're not getting their money back if they win, only the stated amount. They're lost $1.50. If they get the $10 winnings, remember the money's not given back to them, so actually they only end up $7.50. And if you get the $20 winning, they end up $17.50 up. So let's look at these probabilities. So the probability of winning the biggest one is the 2 or the 12, and so that's 2 out of 36. The next winnings here, that's 4 out of 36, and this one here is 6 out of 36, and if we add these up, what do we have? 9 and 9 is 18, 24 out of 36 to lose $2.50. So let's look at the expectation of X. That's going to be negative 2.5 times 24 over 36 plus negative 1.5 times 6 over 36 plus 7.5 times 4 out of 36, add 17.5 times 2 over 36. So let's just clear everything. So we've got negative 2.5, no, I should use the other negative, otherwise it gives me an answer. It's this negative we want. 2.5 times 24, and then we've got take away 1.5 times 6, then we're adding 7.5 times 4 and adding 17.5 times 2. So that gives me -4. And of course, I only needed one line here because it's -4 over 36. All the 36 is on the bottom. I only multiplied the tops together. So that is -1/9. And if we just do 1 divided by 9, that's 0.111 and so on. So the player stands to lose and therefore the house stands to win. And this one's per game, so multiply that by 100 and it's $11.11 approximately.